So the next model we're talking about is going to be that of the V model. Now the V model is sort of an improvement on the waterfall model, or at least it takes care of a problem that people noticed with the waterfall model. And this V model basically takes the waterfall, so the waterfall being, the down, then down, down, and down, and it takes it and it bends it on this sort of implementation down here, and it brings the testing up to the right side. And then deployment is just sort of like maybe the next step to the right over here once all of this is complete. But what this model does is it works this way. So don't think we're going like this and then back up the right side. What we're doing is we're working basically on these layers right here. So we have this top layer, which is this connection between requirements and acceptance testing, then design and system testing, architecture and integration, and module and unit testing. And the reason we do this is because remember in the last lecture we were talking about how there was a problem with this, in that testing is the situation where we find bugs, right? Well, if we find large bugs, we have to go all the way back to fix those bugs. So we have to go all the way back to the requirements, the design, and the implementation to fix those bugs. Well, someone thought, well, if this is the step where we find the most bugs, wouldn't it make sense not to put it at the end, but near the beginning, and do it at each step as we go down? And that is what the V model does. So with this, we have each step, and then we have testing to verify that step. So this right side over here is basically verification. So the right side is going to be us verifying that each one of these steps are actually good before we move on. And this right side is just what we've been doing, the design. Now with this model, we've took this design portion and we actually broke it out into its subcomponents. Remember how we talked about architecture and then different modules and then design as a whole. So that's what we're doing here. We're taking this and we're actually breaking it out so that we can have different parts to test. So the first one is requirements. With requirements, what we have is we have this idea of acceptance testing. Acceptance testing is testing to make sure the requirements are exactly what we want. An example of this would be to just come up with the requirements and try to almost create simulations or potentially come up with documents that would detail each use case. So how exactly are we planning on having the user use the system? And then we're basically trying to almost simulate what a user would do and see if it's going to accomplish those tasks. So we look at the requirements, we try to create a user that would use it and see if there's something that we missed, something that we're not understanding. And this is usually done with the client to make sure that, again, it's acceptable. We're doing what we want to do, and therefore it will be an acceptable solution. The next step is the design. And when we talk about design like this, we're talking about the entire system design. So we're talking about that really top level where we say we're going to have this section, this section, this section, and this section, and maybe just a little bit like we're going to have some communication here and communication like that. And this is going to be the whole thing. So this is the design of the entire system as a whole. And so once we get that, we're going to do some system testing, maybe make up a couple of test cases, write up a little bit of code just to see and make sure that this design is working properly. Then we go one step farther. We actually break into these and we start designing architectures, figuring out how all this stuff works. And then we do integration testing, making sure that this all works together and then that it works together still with the other ones. And then we do all the way down to module testing, which is where we break up these into the tiny modules, the bits of code that are actually communicating with one another. We do that idea of unit testing, which we talked about, and then we sort of go maybe back up the chain to make sure that the rest of it will work with everything else. And because of all of this, because we've done all of the testing in this phase, once we get to implementation and we code it, we're done because the testing was done throughout the entire part of it. And now we're sort of guaranteeing that we don't run into this big area where we're going to have a lot of bugs, that we'll find them sooner and therefore will reduce the cost, because instead of finding them maybe up here on the cost timeline, we find them down here, and we're trying to make sure that we find them before this point and they don't end up cascading all the way up to that point. And so that's what the V model is all about. It's a sort of a next step on the waterfall model. Now, the only con with this is that there's more upfront work in that every step we take, we have to come up with entire testing algorithms. Remember when we were talking about testing, testing is difficult. It's something that is not very easy to think about and also not very easy to implement. So with that in mind, we have to understand that because of the way we're doing this, we have to test at every single section here, and that means that we're going to have more upfront cost. It's going to be more difficult, and it's going to be slightly more complex to manage this software. But it's great if we are maybe not 100% sure. We have sort of an idea of the way that we want to go, but we're not 100% sure on how to get there. In that situation, we might want to use the V model so that we can take steps to keep testing it to make sure that we're walking down the right path.